Hi, 5H. This is for those who missed the lesson today. It is quite important that you catch up with what we have learned today, so that because this refraction is tested in your WA1 next Monday, and you need to know this part of the lesson that you have missed out lah. So at your own time, please view through this video clip until you get uh, all the important things. Yeah. Okay. So recall what you have learned. Recall what you have learned from refraction. If you take out your refraction notes now, you will recall that we have already completed the what is refraction, the why it happened because of the speed, right? And um, because of the speed changes, we have one formula that helps us to calculate the refractive index, right? The refractive index of the denser medium. In your O level, you are always tested light traveling from air to a denser medium, or from a denser medium such as glass or water out into the air. It's always between these two medium. So they are likely always to ask you calculate the refractive index of the denser medium, which is either glass or water. So when you are asked to find refractive index of glass, for example, refractive index of glass, you use speed of light in air over speed of light in glass. And we have completed one example here, if you recall. Okay, this example. When you are given refractive index, the speed of light traveling in air over, and the light went into glass and is traveling at 2.1 times 10 to the power 8. All you need to do is take the speed of light in air over speed of light in glass, and you get the refractive index of the glass. Okay, refractive index of the glass. Okay, down here. Okay, so remember, refractive index of the denser medium such as water, glass, or diamond, all these have refractive index greater than 1. 1 is for air, 1.00 is for air. Anything greater than 1.00 is a denser medium than air. Okay, denser medium than air. They are so-called the denser one. Alright, density is higher than air. So air has a refractive index of 1.00, water is 1.3, and then glass is about 1.5. So you are always told to find refractive index of the air. I mean refractive index of the water, the denser medium, or of the glass. It's never about air. Alright, it's never about air, because air is understood to be 1.00. Now, in the class today, we also did this example 2A and 2B. So 2A, again, you are tested whether you have memorized this figure well. The speed of light in vacuum is also equivalent to in air, is 3 times 10 to the power 8. And then they need you to use this figure in this question, part B. Now, this time, you are given the refractive index 1.5 of this glass. Now, by the way, this list of figure, refractive index, this whole list is not to be memorized. It's not for you to memorize. It's just for you to know different medium has different refractive index. Alright? If you need the figure, it will be provided for in the question, like this one. Like this one. The refractive index of glass is 1.5. That's given. Alright? So you are asked to find to calculate the speed of the light in the glass. So now the speed of light in glass is unknown. Now this one is the unknown. Okay, so if you write the formula, refractive index equals speed of light in air over speed of light in glass, you will be able to come to this if you substitute the value in. You have 1.5 equal 3 times 10 to the power 8 over speed of light in glass. Now from this you cross multiply. Okay, you cross multiply, you'll be able to find the unknown speed of light in glass. Now how do you cross multiply? When the unknown is below the fraction, all you need to do is bring up exchange position, then bring the 1.5 down. Okay, so the equation become like that now. Okay, bring the speed of light in glass that you want to find up. This is the unknown. You bring it up, then bring 1.5 down. So now you have your speed of light in glass equals to 3 times 10 to the power 8 over 1.5. And you press your calculator, you'll get 2 times 10 to the power 8. And since you're finding speed, it should be meter per second. Alright, meter per second. Okay, now I would like you to um, take a look also under this table, what it means. If you look at the formula, okay, in this formula, you see that what has refractive index, this number, okay, got to do with the speed. What is their relationship with the speed of light in the medium? If I were to look at it like that, okay, look at it this way, because speed of light in glass is underneath this fraction in the formula. It means as the refractive index increases, the speed of light in glass, the speed at which the light move in the glass, in the medium, will decrease. It is inversely proportional because of the relationship in this fraction manner, in this formula. Okay, the speed of light in the glass is inversely proportional to the refractive index. So what does it mean? If I look at this list here, this refractive index increases as it go down, diamond being the highest. So if you, I have a statement written below here that indicates the relationship. The higher the refractive index of the medium, the higher it goes, like 1.3 to 2.42, the higher the refractive index. You know what it means to the speed of light traveling in the medium? The slower the movement of the ray in the medium. Okay, the higher the refractive index in the medium, the slower the speed of light in the medium, the slower it moves. And what does it mean? It means the more the ray will bend from its original path. The more it bend, the more it refract. Okay, the higher the refractive index, the more it bend. And how does it bend? We are coming to the drawing. How does it bend? We are coming to the drawing now. Okay, to the drawing. There are three three rules by which you have to understand how ray move as they enter in from one medium to another. First of all, light travel in a straight line. Okay, and the ray of light will bend upon entering at an angle. You must know that when it enters at an angle, it will start to bend or refract. But how does it bend? Does it bend towards the left or towards the right? Then now there are three rules that you have to follow. So we are going to go through 1, 2, 3. Then we will do some exercises. Okay. Now, first of all, understand when there is no angle, when the ray shine vertically down. Can you see my red line I'm drawing? This diagram number 1. When ray shine perpendicular to the surface of another medium, be it water or glass, it can be water, it can be glass, but so long it is shining 90 degree to the surface, you know what will happen? Let's take a look at the clip, one video clip here. You see what will happen. Okay, there. Okay, let me play it. Hold on, let me play it. See, that if you shine the ray perpendicular to the surface, you notice the ray go through the glass and out of the glass in a straight line. Okay, in a straight line. But once you go at an angle, you notice at an angle here, once you go at an angle, the ray will bend. There will be a refraction when it go from glass out into the air. Okay, the ray start bending. Only when it is at perpendicular position, perpendicular to the surface, it will go straight through. So the first principal ray I want you to notice is this. first principle ray, I want you to notice is that you can write this down. When the ray, or let's take a ruler and a pen or a pencil to draw this first. When the ray is perpendicular, diagram number one, at the surface, it will go straight through the water. If you shine it out from water, it will go out to the air in a straight line without bending. So can you draw this first ray and an arrow going downward? Since the incident ray, the ray is coming downward, it go through the water also straight down and is perpendicular to the surface. Okay, so rule number one, when the ray is perpendicular to the surface, it will go straight through. There's no bending, no refraction, but the speed will slow down. Okay, the speed will slow down. At for this ray that go in, the speed is slower. The speed is slower. However, it will go straight. There's no bending. Okay, so what you have to take note here, can you write down in your blank? Okay, when the ray is perpendicular, when the ray is perpendicular to the denser medium surface, the ray goes straight without bending. Okay, now the angle below, the angle at the bottom, hold on first until we go through diagram 2 and diagram 3, then we'll come back to diagram 1. Now diagram 2 now, there is a normal line. Okay, sorry. There is an angle now. You notice there's an angle 45 degree from a normal line. Now, in refraction, again, normal line is very, very important. It is an imaginary line dotted with no arrow. It is an imaginary line that allow you to measure angle of incident, the incident angle, which is between the normal line and the incident ray. Okay, normal line and incident ray. This is known as angle I. Okay, now this time the ray will bend. It should not go straight through. The ray will bend. Okay, how does it bend? I'm going to show you. I'm going to show you. But you write down the rule first. The rule below say when the ray of light move from less dense air, like for example air, to a denser medium, like for example water, into a denser medium water, the ray will bend towards the normal line. It must bend towards the normal line. What do I mean by bend towards normal line? Let me show you in my words document page, okay, of this diagram number 2. Okay, you follow me, this diagram number 2. Lorna. Okay, if you look at uh, my words document here, I try to demonstrate to you using by moving my arrow to show you what it means. You see, you don't draw anything yet. Listen to my explanation first. Okay, listen to my explanation. You see, between this air and water, if there was no water, the light would have gone through straight like that. Am I right? The light would have gone through straight like that if there was no water. But now the rule say once it go at an angle from air less dense to water, the denser medium, it must move towards the normal line. Move towards means this way, see, move towards means move towards the normal line. Who is the normal line here? Normal line is this one. Okay, I try to color it green. This is the normal line, right? Okay, this line is the normal line. Okay, normal line. So let me color the normal line so that you are following me. So I paint this normal line yellow here. Okay, yellow. Okay, this normal line yellow here. So what does it mean here? Without the water, it would the original ray would have shoot into this direction, straight line. It will travel in a straight line. But now it is going into the water, less dense to denser medium. It must move towards the normal line. So move towards normal line means like that, towards here. Now if you move this way, it means move away from normal line. You see, this is normal line. So Original path is like that. If you move this way, it means move away. Move this way means move towards. Okay, move towards. So the rule says less dense to denser medium, air to water, it move towards. So you just draw in your notes, you just draw a straight line with arrow, move towards anywhere in between here, this yellow and this original path, anywhere in between, it shows that you are moving towards the normal line. Okay, towards the normal line, and therefore the angle R is here. So can you also state the angle R? Angle R is here. Okay, angle R. So I go back to your notes now. Let's go back to your notes. You are supposed to draw this. So the rule says as you go from water to air to water, it must bend towards. So bend towards. Okay, bend towards. So use your ruler and your pencil. You must draw straight line. If you use freehand, they will mark you wrong. Okay, you must try to draw straight with using ruler. So it goes like that. Now on the screen, I can't use ruler, so my line doesn't look straight. I try my best. Okay. Okay. So this is the refracted ray. Now you have the refracted ray. This is the refracted ray, and the refracted angle is always between the normal line and the ray. Between the normal line and the ray. That's why you need the normal line. If you don't draw a normal line, you most likely will go and put this angle as the angle I. This is not angle I. I mark, maybe I use a different color. Okay, this is not angle I. Okay, this angle is not angle I. Angle I is between the ray, incident ray, and the normal line. The normal line. Okay, normal line is here. This is the normal line. Okay, all right. And the refracted ray is this one. You just drawn an angle R. Can you please mark your angle R? Okay. Now let's look at our diagram and see. My angle R, is it bigger or smaller than angle I? Because it moved towards normal line, it must have been smaller than my angle I. So it must be less than 45 degrees. So below this line, can you please write down? Angle I is greater than angle R. Angle R is smaller than angle I. Okay? Now let's go to the third diagram now. Third diagram, this time light go from water out into the air. So the rule says when light move, okay, when light move, let me use my cursor. When light rays move from denser to less dense medium, the ray bends away from normal line, away from normal line. It bends away. So again, allow me to demonstrate from the words document. I demonstrate from the words document. Okay, this time, let me draw this ray this time here. Without the water, without the air, let's say totally is water, the light ray would have gone this straight path, this direction. Now I always use this straight path, original path as a starting point, as the starting point to let you know that your bending should only happen within this quadrant, within this quadrant. Your bending is within this quadrant only. Bending is within this quadrant. Okay? Alright? Just like previously, let me go up. Sorry. Just like previously, the bending only happened within this quadrant. Notice? Okay, the bending happened in this quadrant. Because the original path, by knowing where the original path moved, you will know which quadrant it is. It is moving. Okay, you will know which quadrant it is moving. So you see, again, I want to stress this point. Hold on. I want to stress this point. I always mark the original path where it will go first. When I know the original path is going here, you see this one, original path is here. then I know my bending is, again, my bending is within this quadrant. Okay, my bending is at this quadrant. All right, around here. Okay, now how does it bend? According to the rule, it says the bending is away from normal line, from water to air. From water to air, you bend away. So bend away means the normal line is here, down here. This is the normal line. Bend away means bend this direction. Bend away from normal line. Away from. If you bend this way, is bend towards the normal line. So you should bend away from normal line. So you should draw this ray. Okay. So let's go back to your notes. Go back to your notes now. You should draw this one now. Bend away means bend this side. Now where is our angle R? Let's label our angle R now. Angle R now is this one. Normal line to the refracted ray. This is the angle R. This time, is the angle R bigger or smaller than angle I? Your angle I is 30 degree here. Angle I is bigger, right? So below the line, can you please write it is bigger now? Angle I this time is smaller than angle R, or angle R is bigger than angle I. Okay? Previously it was smaller. So now you know where angle I and angle R is measured. Can we ask ourselves back to first diagram, what is my angle I and what is my angle R in this diagram? Let's look at one applet I show you. Okay, if I shine my ray this way from air to glass, air is the white portion, glass is the purple portion, okay, and I put my protractor here like that, circular protractor, 0 is here, and my refracted, my incident ray is at 60, so the angle of incident from normal line to incident ray is 60 degree. As I decrease my angle from 60 to 30, my refracted angle also decrease. Okay, also decrease. As I decrease some more to become perpendicular, what is my angle now? My angle from 60 to 30, and if it become perpendicular, my incident angle now is actually 0. It is not 90, it is 0. Okay, so go back to your notes now. Please write here, angle I is 0 degree and angle R is also 0 degree. What does it mean? It means your light source is shining light perpendicular to the surface. So below here, down here, can you write this in? Angle I equals 0, angle R equals 0. Alright? Now, just now I've demonstrated with the applet here again. With the applet, I wanted to show you as my angle I increases at 30, angle I is 30, angle R is at about 20, like that, is about 20. But as my angle R increases to angle I, incident angle increases from 30 to 60, 30 just now, now 60. Notice my angle R also increases to 30 something. So the relationship, back to your notes, back to your notes, there is a relationship between angle I and angle R. As angle I increases, can you come to here? As angle I increases, angle R also increases. Write that down. And today in class, we have also gone through practices on how to draw refracted ray when the ray of light shine onto the surface at an angle of glass or water at different position. Okay, let's look at horizontal position first. Horizontal position. The surface is horizontal. So let's say this is a piece of glass. Okay, this is a piece of glass. A piece of glass like that. Okay, a piece of glass. And light ray is going from air into the glass. Going from air into the glass. Okay, and I have a normal line drawn here. Remember, normal line is for you to help you identify your angle I and R. Very important. Okay, normal people will draw normal line. Okay, remember that. Okay, now practice how you draw all this on your own. Then confirm your answer with me. You can actually pause the video clip here try to draw it yourself with a pencil, then confirm your answer with me. Okay, so I will just go on here so that you can check your answer. So from air to glass, what did the rule say? Bend towards or away? It will bend towards because the speed of light becomes slower. When it go inside glass, the speed of light becomes lower, it will bend towards. Let me change the color. Okay, it bend towards. At which sector? Which sector? Because if you don't identify the original path, some student will go and draw on this side. Some will go and draw on this side, which is wrong. Okay, so I erase here. The bending should happen on which sector? Remember, it should be at this sector. This sector. Why? Because that is where the original path is. If there is no glass, the original path would have been like that. That would have been the original path. Okay, but since so it will be in this sector, since it go from air to glass and it slow down, it bend towards normal line. So now bend towards means like that. It come towards here. From its original path, it come towards the normal line at here. It bend towards the normal line here. Right? Normal line. Okay? Bend towards normal line. So let's identify the angle I, angle R. Identify the angle I, angle R. Angle I will be, incident ray is this on top, so this is my I. Angle R will be here. Okay, angle R. Between the ray and the normal line. Now try B yourself. Now this time glass to air. Without the air, let's say the whole thing is glass, the light would have traveled straight through like that. It would have traveled straight through like that. That tells me the refraction, the bending happened at this sector. The bending happened at here. Now, go back to the original rule. Light travel from glass denser to less dense, bends away from normal light. Away. Away means this direction. Okay? What angle doesn't matter. You don't need to measure what angle it is. Just show that you are bending away. You are bending away. So draw the line with the arrow. Remember, light ray must have arrow. No arrow minus mark. Okay? So bend away. Now, if it bends away, then the angle R is here. Remember, this is the refracted ray. This is the refracted ray. Okay? If this is the refracted ray, then this is my refracted angle. Then my angle I, incident ray is on top. Angle I is here. Okay? Now, second diagram. Now C and D. C and D, now I change the position of the glass to vertical. Position of the glass become vertical. What does it mean? It means now the glass is like that. Okay? Okay, the glass is like that. And your air is entering the vertical glass in this format, this position. Now, what do you have to draw first? Do you draw refracted ray straight away? Yes, you must draw normal line first. Do you notice there's no normal line? So draw normal line. Now, when it's horizontal position, normal line is 90 degree like that. So when it's vertical position, where do you think the normal line would be? The normal line would be, let me use blue color, use a different color, green color. The normal line would be here, okay? 90 degree to the surface. So this is my normal line now. Okay, I cannot use ruler to draw on the screen, so I'm trying my best to draw straight. You have the ruler with on your paper and table. You should use your ruler and pencil, okay, to draw straight line. Straight, dotted, imaginary line, normal line. So this is normal line, okay, normal line. Okay, now this normal line will now guide you how to continue drawing. Air to glass. Come, air to glass, bend towards or away. It will bend towards normal line. So instead of going straight like that, going straight this way, original path, it will bend towards. So towards means this way. Towards who? Towards the normal line. Okay, bend towards the normal line. So where is my angle I, incident ray, with the normal line to the incident ray, this is my incident incident angle. Refracted ray, and therefore this is refracted angle. Angle R is smaller than angle I. Okay, now draw D yourself. Try to draw D. Let me mark my, again, draw your normal line first. Draw your normal line first. Okay? Now, from glass out to the air, which sector should I be drawing? Which sector? The original path sector. Original path is going this way, going this path. The original path of the glass. If there was no two medium, the glass, the air, the light would have gone this direction straight. So you should be drawing at this sector. Okay, this sector. So now ask yourself, bend towards or away? Glass to air, bend away from normal line. So bend away. You should bend this side. Okay, bend this direction. So where is my angle R? Angle R. This is my angle R. This is my angle I. Okay. Now for those who find that vertical position is difficult, you can always orientate your paper to become horizontal. Okay. Those people who don't like, you know, you can always orientate your paper so that the interface become horizontal like this. You can always orientate, right? Orientate until it become horizontal. Okay. Now, diagram E and F, I would like to show you. Some students see slanted surface, they get very frightened. Slanted surface between air and glass. Again, there's nothing to fear. Just turn your paper until the diagram becomes the interface air between air and glass. The interface, turn until the interface become there, until the interface become horizontal to you. You can always turn the paper until it become horizontal. When it become horizontal, things become clearer. Now you can draw your, you can draw your, you know, you can start drawing your normal line first. After you draw your normal line, then ask yourself, air to glass, and which sector should it happen? Original path is here, original path. So it should happen within this sector, okay? This quadrant here. Now that it is at this quadrant, air to glass is bending towards the normal line. So towards normal line means bend towards like that. Okay? Bend towards. So back to your notes, it will look like that. Then if I, okay? So back to your notes, when you rotate your notes backward, then it should look like this. So I draw here, normal line, right? You can always turn it to face yourself, normal line. Then original path is at here, original path. So this is the sector you should be drawing at. Let me erase that. Now I use a different color. Bend air to glass, bend towards the normal line. So towards is like that. Okay, bend towards. Now let's draw our angle, angle I, between the normal line and the incident ray, angle I. Between the normal line and the refracted ray, angle R. Angle R is here. Very small angle. Okay, angle R. Now similarly for F, again you don't like slanted surface, just rotate. There, I show you F, show you F. There, you don't like slanted surface like that. Rotate until it becomes horizontal to you. Horizontal. Okay, now it's horizontal. Then you can start drawing your normal line. Look at the sector where it bend and bend towards or away. glass to air bend away. Okay, so back to your notes again. Then you can orientate, but let me just draw straight. I'm used to it already. I don't have to orientate. So normal line means 90 degree to the surface, 90 degree to the surface. Draw your normal line. Okay, this is my normal line. All right. Now glass, uh, uh, light ray go from glass to air. Original path would have been here. Original path. So it should happen at this sector, the bending. So let's erase this. But the bending says glass to air bend away from normal line. Bend away means bend this side. Let me draw again. I try to draw straight. Okay, bend away. This bending away. Okay. So now the angle. Okay, the angle. This is my angle. This is my angle. So who is I? Who is R? Okay. Incident ray, angle I. Refracted ray is here. Refracted ray is what you have drawn. The bend away one. This is my angle R. Angle R is bigger than angle I. So you must get used to three type of position. Flat one, horizontal, vertical position, interface, and slanted position. Because there are three types of diagram you must know. The triangular glass prism, how the light ray will go through and come out. The semicircular glass block, how the light ray will go through and come out. And the rectangular glass block, how the light ray go through and come out. But today in the class, we skip this part because I had to introduce the second formula to calculate refractive index. The first formula was speed of light. Remember first formula here, speed of light. Okay, first formula, this one. Okay, using speed of light in air over speed of light in glass to find refractive index of the glass. But now, if your problem is this type, with angle one, with angle, turn to the next page, with this angle one, if you see this, when you are given a diagram with angle 50 degree I, R is 30 degree. Okay, now this type, they will ask you to find refractive index of the glass. It is never about air one. Find the refractive index of the glass equal how much? Now there's a second formula. You look at the right side, second formula. Okay, is sine I over sine R. When you are given angle, just take sine 50 degree over sine 30 degree. Once you identify the angle where they are, where's I, where's R. So that's why I tell you, knowing the position of the angle is very important. Because O level can give you different angle at different place, you must identify the angle first, the I and the R. Okay, so let me review this part. Practice with your calculator, press sine 50 over sine 30. You should get 1.53. Is that close to our theory that refractive index of glass block is about 1.5? So when you calculated, you get 1.5 something, you know your answer is correct. It cannot be 0 point something. If it's 0 point something, means you have put the fraction wrongly. You have put sine 30 over sine 50. The bigger angle must always be on top. Then you will get 1 point something. 1 point something tells me that this refractive index, this glass, has a higher density than air. Because air is 1.00, then glass must be 1 point something already. Okay, so you should not get 0 point something. All right. Okay, now try this one. Now, that is for, you see, this formula only works for incident angle I in the air. Incident angle I in the air here. And then the R is in the glass. The R in the glass. Based on this diagram. So incident angle I in the air. Can you see here? Incident angle I in the air and the R is in the glass. But what if the second scenario, look at the bottom here. What if light travels from water to air, denser to less dense medium? This time I is not in the air. This time is R in the air and the I is in the water. The 29 degree I is now in the water, denser medium, but my R is in the air. Now how will the formula become? Look here now, the angle, the formula now become this one. You must remember, it's tested in your WA1 next Monday. Okay? Now it becomes sine r over sine I, which means now you have to put what in the formula. It becomes sine 40 degree over sine 29 degree. So identify your I and the R properly. Then you must know how the formula will overturn when it is going from less dense, when it goes from less dense to denser medium, less dense to denser medium. Okay, down here, overturn. So some students ask me, Cher, what if I forget? What if I forget which I should it be I on top or R on top? Then I below or R below? Which formula goes for which diagram? Don't worry. Whatever diagram given to you, identify your I and the R properly first. Your I and the R. Then you must remember sign the bigger formula, sign the bigger angle on top, and then sign the smaller angle below. Sign the smaller angle below. So even if you forget I is on top or R is on top, don't worry. Identify your I and the R properly first. Then go for the bigger angle on top, smaller angle below. Only then when you work out you calculate, you'll get 1 point something, 1.33. You must get 1 point something one. You get 0 point something, means you put the angle wrongly already. Okay? Now the danger in O-level question, let's try question 1, question A. The danger in O-level question is this. Let's look at this A. Let me enlarge. First of all, um, can you please, sorry, check that this angle is very clear to you. This angle below here, down here, this one is 25 degree. 25 plus 65, okay? 25 plus 65 is 90. Normal line is here, okay? So now this question, you see O level give you 4 angle, 65, 25, 52, 38. Now sine what over sine what? Ask you to calculate refractive index of the glass. Now which angle over which angle? What is your first job? What must you first do? Would it be, do I use 42, 52, 25, 38, 25, or 65, 38? See, very confusing, right? So that's why right from the beginning, the fundamental is to identify your angle I and the angle R. So can you first tell me who is your angle I, who is your angle R? Incident ray is the one that comes down, right? Incident ray that comes down to the surface glass. So if this is incident ray, who is my incident angle? The 38, 38, this one, okay? Between the normal line and the incident ray. That is my angle I. So my angle I is 38 degree. Okay. Who is my angle R? My refracted ray is here. So my angle R is between the refracted ray and the normal line, which is this one. So my refracted angle is 25 degree. Okay. Now therefore, refractive index is, who is the bigger angle? Bigger angle is the 38, right? The bigger angle is this one. Okay. So when I work out my sine I over sine R, I must use sine 38, the bigger angle on top, smaller angle below. Sine 38 over sine 25. Now try pressing your calculator. Don't believe my answer. You have to press it yourself to know it. Okay? Press calculator, you will see that it's 1.46. Okay? Alright? So this was where we have ended so far for today. Tomorrow we will have to go through the rest of the question in different form, but I think I will, in the one period, I have to rush very fast. I have to again recall how to draw uh, light ray going through the glass block. Okay, going through the glass block first. Then after that, we will solve this question. That's the end for today. Okay, thank you.